Hello students, now we are moving to the next question, which is question number 6 taken from the HL exam May 2025 times in 1. But this is the same question in question number 5 in SL paper from the same year, right? Now this question is about the forces by the field on the charge when it enters into the electric field and magnetic field. So you can guess that this question should be about from the unit D and D.2 and D.3. Okay, let's start. So we see that first of all, an electron is accelerated from rest. Okay, it means that that electron gained kinetic energy, right? From the energy point of view, it was at rest, U is equal to 0. All right, and with the help of this potential difference, which means that if we create some potential difference between the parallel plates, that electron will be attracted towards the higher potential side, and during this it will accelerate, and we will calculate that acceleration later on. And due to this acceleration, its velocity will increase uniformly. Now you have already idea. Let me show you the diagram. So students, you see I have set the parallel plates, and there should be an electric field between the plates, and that should go from the positive to the negative. And this is uniform field, you know, it already means that all the lines are parallel to each other between these plates. Okay, and on the edges this field is non-uniform like this. Okay, anyways, an electron, they said, gains this velocity 9.4 times 10 power 6 meter per second when it just escape this field, right? When, so it means that you can guess this electron was initially at this point where its speed was 0, and it accelerated and it's going in opposite direction of the field. So it is attracted right at this point, when it is just exiting, its speed is 9.4 times 10 power 6 meter per second. So you have to find out the electric potential. Right now, what is the electric potential? Electric potential, basically this is the potential difference between the plates. This V is not a absolute potential, this is the potential between the positive and the negative plate. And we can define this potential as the work done per unit charge. Now you know that due to the work done on the charge, on this charge, it will gain kinetic energy. Energy transformation has been happened, the potential energy has been decreased and the kinetic energy is gained. So what do you think, what is that gain in kinetic energy over charge? So we can find out easily, this is the gain in kinetic energy over charge, right? So the potential is equals to mv square divided by 2 times E, because that is an electron. So let us put the value 9.1 times 10 power negative 31 kilograms times the speed square. So I'm going to put all the values and you can see what answer do we get. 1.6 times 10 power negative 19 coulomb, and the answer of this quantity will be in volts, right? So students, the potential difference is 251.27 volts. Okay, so this is a potential difference right now. And now let's go to the next question. As you see, this is the same. Okay, now this electron, where the potential difference we have just calculated is 251.27. Now this electron, it has entered into another set of plates, right? These plates are different plates, and these parallel plates are set right after this set of plates. Why? Because when electron has entered in this region, means it has entered in this region, now it will obviously move towards the positive plates. Okay, because of the electric force applied on the electron, so it will move in a curved path. So let me show you clearly in the separate diagram for it. So students, just imagine the energy that this electron has gained as a result of this potential difference in the previous set of plates. Due to that energy, its speed is finally 9.4 times 10 power 6, and it's moving horizontally. So just imagine now, it is right now, it is here at this point in the middle of the plates. All right, whereas they are clearly mentioning that the distance between them is, between the plates, is 4 centimeter, and this distance will be very important for us later, we will use it. Okay, now, so the electron will move, it is very important to determine the trajectory of electron, okay, because electron is a negatively charged particle. It has an initial velocity to the right, but you know that it will be attracted towards the positive plate. Why? Because of the electric force upward. Now, important thing that this electric force is F is equals to EQ, right? When we say electric field is uniform between the plates, and of course that is correct, that the field is in the form of these parallel lines, right? So the value of E is constant everywhere between these plates, and Q is also constant. So it means that the force that is applied on electron right at that point when it has entered, and even till the last second, that force will be constant and upward. Okay. Now, due to this force, what will happen? It will not be able to keep its trajectory horizontally. It will hit maybe the plate, or if this force will be weak, then might be it will go outside the field, right? But it all depends on the magnitude of the force, right? So, as I have told you, that the force is upward, and that force is a constant force, and that force is EQ, which is a constant force, and this constant force will produce a constant acceleration, which will be also upward. So wherever the electron will be at any point, you can see clearly that the direction of acceleration is directed upward. That is the answer of our this question, that it is vertically upward. Now, this acceleration is constant. So just imagine it is moving with the constant acceleration, and it is executing the two-dimensional motion, because it is moving horizontally as well as it is moving vertically. And how much it has moved vertically upward? That is 2 centimeters. So you can resemble it with the projectile motion. All right. That is exactly according to the projectile motion. So that's our next question. Find out the magnitude of the acceleration. So right now, if we apply the Newton's second law, right? So we see that what is the resultant force exerted on it. So the resultant force is Fe, that is equals to EQ, right? And that is equals to Ma. We can find out the acceleration by this equation, right? And right now we don't know about the value of E, right? But we know in our syllabus this formula is included for SL and HL. All right, so you can put the value here. Potential difference between the plates. Now don't do this mistake right now. This V is 30 volts. As I told you, it is the separate set of plates. All right, so this V is 30 volt, not the 251. All right, now, so what equation do we get? VQ over MD, right? So V is 30, charge is 1.6 times 10 power negative 19, mass of electron is 9.1 times 10 power negative 31, and the distance between the plates is 4 centimeter, so 0.04. Let me check. So our answer of acceleration, which I have calculated, is 1.31 times 10 to the power 14 meter over second square. So this is an acceleration due to this force that is vertically upward, right? And you can see it is about 10 to the power 14. So that is our answer. So this is a mark scheme for the first part, and this is the mark scheme for the second part. Okay, now let's move to the next part. The electron collides with one of the plate. Determine the distance the electron travels parallel to the plate. Now, dear students, as you see in this diagram, I have shown you that this electron is already moving two-dimensionally. It is moving in a projectile path, right? And according to this, electron will hit right at this point. It will hit at this point, okay? So how much it has traveled parallel to the plate? So it has traveled two distances simultaneously. It has traveled this distance horizontally, which is parallel to the plate. This is a parallel to the plate, all right? And as well as it has also moved vertically upward simultaneously. That's why it is two-dimensional motion. So it has traveled total 2 centimeter. That's a y distance, but how much the distance has traveled? Now, remember, as I told you, we can consider it projectile motion, and in projectile motion, since its acceleration is only vertically upward, it have no acceleration horizontally. Remember that. It means that we will consider its velocity, horizontal velocity, to be constant. Okay, so we have to just calculate the time that it will take to hit the plate, and then we can find. Let me show you. So now I explain you what I exactly mean, right? So this can be called its initial horizontal velocity, which we have already calculated. Okay, so they have given us, that was I think 9.4 times 10 power 6 meters per second, right? Okay, now I mean to say that this velocity will not change at all the points. Its magnitude as well as its direction at all the points is along x-axis and the same value, right? Now, what we have to exactly find in this question, we have to find the distance that it will travel horizontally. Okay, we have to find this distance, and you know that it's have a no acceleration in the x direction. So even if you try to apply the Suvat equations, right, because we can apply, because it is moving with a constant acceleration. All right, so I will take here the x component. Okay, 1 over 2 ax square, and dear students, this is 0. So finally, what do you get? Horizontal velocity, initial velocity, multiplied by the time taken. All right, now what is the time taken by this charge, right? This is important. What is the time taken? So for this, we have to consider its distance that it has covered actually along the y-axis. All right, it has moved 2 centimeter vertically upward. Okay, so I have to find the time t, I have to find the time t. Okay, what we need to do, we will apply Suvat equation once again, but now this time not for the x-axis, rather for the y-axis motion. So I can say Sy is equals to initial velocity in the y-axis direction times t plus 1 over 2 into ay into t square. Okay, now you see that when it has just entered here, it has a no velocity in the y direction. It's purely entirely in the x direction. So that's why it is 0. Okay, so this equation reduced to Sy is equals to 1 over 2 ay t square. And this ay is actually the same acceleration produced by the electric force which we have just calculated in a previous question. All right, so if you separate the time, then what do we have? So we will have the time t will be equal to, you can take the 2 on the other side, so it will be square root of 2 vertically distance covered divided by the acceleration. All right, now that it is 2 times 0.02. Okay, because it has traveled 2 centimeter upward divided by the acceleration, which is 1.3 times 10 power 14, and it will result time 1.74 times 10 power negative 8 seconds. So you see that this time is so small because the electron was moving at a very high speed. That's why. Okay, let's go back. Now you remember what equation that we have formed that can give us the distance covered in x direction? Obviously this equation. Now we have to just simply multiply the initial velocity in x direction multiplied by the time, and I'm substituting the value. So students, its distance is 0.16 meter, so it means that it will cover 16 centimeter horizontally. All right, so this is the answer of this part C. Right, so this is our answer, 0.16 meter. I took more time because I have explained it in very detail. Now let's just come to the last point, and you see this is a setup now where we see the electric field and magnetic field simultaneously. All right, now according to this question, when the electron will enter into this sector, in this section, right, it will go undeflected, it pass undeflected. Okay, now you know that this electron will experience electric force as well as the magnetic force. So there is only one case in which it can go undeflected, and that is if it moves, because it is moving with a constant velocity. All right, it means there's a no acceleration. It means that sum of all forces on the electron is zero, and which in other words means that the force, electric and the magnetic forces are equal and opposite of each other. All right. And by the way, this setup is called, dear students, velocity selector. It's a very famous type of question, velocity selector. All right, let me show you in another diagram. So students, this diagram is just for the reference. As you see that electric field is applied vertically downward, whereas the magnetic field is applied in a z direction. Okay, and the charge is moving in the x direction. All right, so you can imagine that velocity, electric field and magnetic field are all perpendicular to each other, right? So if we produce such a setup, if we make such a setup where the electric field and magnetic field are perpendicular, just like this, or just like in this diagram, the magnetic field is going into the plane, means in the z direction, and electric field is going downward from the positive to negative, it means along y-axis, whereas an electron is going in a x direction, then there's a possibility that at a certain velocity it can go undeflected. All right, and we have to find the magnetic field. All right, so now see carefully that this is an electron. All right, electric field is going downward. All right, so it means that obviously the the electric force will be upward because it attracts the electron. Now the magnetic force should be downward. Only in that case it can go undeflected, and you can apply the right hand rule, okay, on this. So magnetic force will be downward, and then it will go undeflected in this direction with a velocity that we already know. Okay, so it means that EQ is equals to QVB. All right, and Q is cancelled out, and the B is equals to E over V, right? And the magnetic field strength is equals to the value of electric field strength that we have already, it's the V over D divided by, this is the velocity. Okay, this big V is the potential and the small v is the velocity, so it will be equals to V over D small v. All right, and now I'm going to put the value. So our answer is 8 multiplied by 10 to the power negative 5 Tesla. That is the magnetic field strength. If this will be magnetic field strength applied into the z direction, negative z direction means into the plane, then this electron can go undeflected. I hope you understand this, all the solution. That was a very detailed explanation, and let me know if any question.